Hello, this is Bryan Melendez with my DC motor. So this is what I got. I'm actually using an 18 volt battery because, you know, why not? I wanted to have a fun time using this one right here. I tried it out with the 9 volt. It gets it moving, but it doesn't really work for a whole minute. And then here's what I got. So I wrapped some insulated wire around this piece of plastic that I got from Home Depot. It was actually like for plumbing, but I just cut like the top of it off because I couldn't find anything better. So I wrapped that around here quite a few times. I think it was like 10 feet of wire wrapped around here. Then that's connected down through here, through this little wood dowel. That's connected at the end with a little stop at the end. I mean, you know, plastic. That's really just tape, but yeah. Got some on this side too. But yeah, it spins like that. It's connected to these wires, which connect to this copper ring that I cut in half with a Dremel tool and nothing else. And then connected to that, I have these two wires, which got like some pressure on them, yeah, to make sure that they are holding in place. Kind of just tape them down. I would have used some, well actually I just used electrical tape to cover this wire because this wire is not insulated. I didn't have to strip it or nothing, but yeah. I have, you know, two things to hold the dowel in place. I kind of just screwed them in. One there, one in the back. It's actually pretty cool because it lets me control like side to side, you know, if it's too close to the magnet or whatever. Hopefully I don't have to change now. Okay, it's good, and it's good. All right, and then my magnets. I couldn't find any neodymium magnets, so I just got, I think they're ceramic magnets. I got 4, put them here together. Got 4, put them here, opposite sides, so I don't know which one. I think this one's north and this one's south. And then, yeah, they are taped to this piece of wood. This wood is screwed in to 2 other pieces of wood because I didn't realize how large this little rotating part was. So it's connected to this big block of wood. So like the whole thing just moves around, you know, if you need to. And that's connected to the wood, these wires. So the way it works is as I connect these wires to either my 9 volts battery, right, like this, I literally just put it together. And that causes that to move. So it moves a little bit. I couldn't quite get it to work too good there. But yeah, the wire, the current will flow through the wire, which I had to wrap it with electrical tape so I didn't shock myself again. That connects through this piece of copper, which is connected to the wire, which is then wrapped around a few times. And then it eventually comes out through this wire, connects to this, and then goes back to the battery. So what this ends up doing is when you run current through wires like this, it creates a magnetic field. The more wires you have, the stronger the magnetic field. So in this case, because the wires are running in this direction, or I guess if I hook it up with negative, right? Yeah, I'd be running in this direction, the electrons, it's gonna create a magnetic field, right? Which will turn this into a electromagnet. And because it is already an electric field with these 2 on the side, let's say that the electric field, the magnetic field is running this way. And if this one's going this way, it will want to align with it, right? That will create a torque, which will spin the shaft. When you spin the shaft, because this ring is cut in half, whenever it goes over this little slit, it will now switch it from going through this wire, in this wire, out this wire, into switching it from being now in through the other wire and out through the other wire. So it will flip the magnetic field. So let's say initially it's pointing up, and so that will align it to rotate clockwise, right? Once it switches to the other way, it will flip it to now the magnetic field is going up and it's aligning. and then it will switch it to where now the magnetic field is going the opposite direction because the current is going the other way. So then this will be pointing, I guess, to the left, and then that will want to rotate to go this side so it lines up. So basically I'm just flipping the magnetic field from going like this, from going up, and then it's rotating that way. As soon as it switches through these little slits, it will then flip the magnetic field and it will continue rotating over and over. So yeah, it's actually quite heavy. I probably could have used a little less wire. And I'm using a 18 volt just for fun, really. It creates a little bit of sparks, I think, because I know normally with a DC motor, you would have, instead of just having one magnet, electromagnet, you would have it be like multiple. So you'd have one sideways, you'd have one vertical, or diagonally. So you'd have like continuous power, but kind of ran out of time. And I couldn't really find anything that I could like create that with. So this is what I came up with to work. It's a little rough, but it works pretty good actually. So I'm gonna run it now for a minute straight. Here I had my girlfriend's phone. I've actually been in here for a minute. I was working on it for quite a while. I had a lot of different iterations because I chose the wrong wire a few times. Initially, I tried using this wire. This, it's like pretty thick. I don't know how thick it is. Like a 10 gauge wire. But it didn't really work out too good. It was hard to use because it was so thick. It kind of held its shape. Like, let's see, I bend this up. It's gonna stay like that. It's really hard to bend back, or relatively difficult to bend as opposed to like this normal wire. I think this is a 14 gauge insulated wire. But yeah, okay, I'm gonna run it now. Gotta get the timer going. The timer can sit against this or stopwatch. There we go. So first I'm gonna connect it to here. Sorry, I'm working on it. Should have just bought a switch, but kind of have work in like 30 minutes, so I kind of have to film this now. It started spinning. Oh, my bad. Let me start the timer. Okay, and then I'm gonna just connect it here. Connect it here. Oh, where am I missing? There, I gotta make sure these are both touching. Maybe I should put more electrical tape on here. Yeah, maybe I should put more electrical tape. Let me start over with that timer. All right, start over the timer. Okay. Pretty cool, man. Shaking a little bit, but I gotta move it this way. Yeah, if I put like a little bit more slits in it and have like that continuous torque, it would have been a little bit better. I'm gonna go a little bit longer because I know I kind of messed up there by having to leave it. Probably should have clamped it down or something. I kind of put it on this table I had. Okay, so yeah, that's pretty decent. Pretty cool, actually. I like that it's so strong. Maybe I could have used some better magnets and lighter materials. I wanted to use plastic. I didn't really have any tools to like deal with the plastic easily. But yeah, there we go.